And welcome to Education at SSBJ online video tutorials. We shall take a second equation of motion and its proof by graphical method. There are different methods by which we can prove second equation of motion. In the previous video tutorial, we have seen first equation of uniformly accelerated motion. Here when we talk about motion, it's a uniformly accelerated motion, right? And we have discussed in the previous video tutorials, please go through that, the meaning of what is uniformly accelerated motion. However, we shall see in detail how to prove this second equation of motion by a graphical method. We shall take a situation here. As usual, we shall write velocity on the top and time at the bottom, and simultaneously we shall also draw the graph of velocity against time. Right? Please remember, y-axis is for velocity and x-axis is for time in second. Both are positive, right? And let us assume that a body moves with some velocity, and on first second its velocity is 2 meter per second, right? Its velocity is 2 meter per second. Please see this. I have taken 1 second here and 2 meter per second is on y-axis, so the point should come here. And as we go ahead, right, you will find the velocity of the car remains same, right? Even at 2 seconds, its velocity remains same at 2 meter per second only, right? In the same way, at third second, we have got a velocity again 2 meter per second, and then so on, right? Now, if this is the case, we can ask ourselves, is there any acceleration in this? And what do you mean by acceleration? Acceleration is rate of change of velocity. So underline change of velocity. Is there any change in the velocity? No, there is no change in the velocity in all those intervals of time. Since there is no change in the velocity, its acceleration is 0. So there is no acceleration. Now suppose if you are given a graph, right, velocity against time, and where you find a straight line parallel to the time axis, and you are asked to answer what is acceleration without having any values on the graph, simply a velocity and time on other axis, your answer should be 0, because there is no change in velocity. So please remember that when there is change in velocity, either increase or decrease, then we can have either positive acceleration or negative acceleration respectively, right? Now, if you can extend few lines on this graph, let's say we have joined these two, and I am going to join these 2 points so that I have got a rectangle which I can call it as A, B and C and D. Now suppose if I want to find the area of this rectangle, area of the rectangle ABCD, it's very simple. It's length into breadth. right? So we can write area of rectangle ABCD is equal to AB into BC. So AB into BC or BC into AB. In both way we can write. Now AB into BC, AB into BC. This BC is nothing but AD only. So in place of BC, I have written AD. Now please find out what does AB mean in this graph. So this particular line, since it is parallel to y-axis, what does y-axis indicates us? It's a velocity. So this particular point is giving us a particular value of velocity which is 2 meter per second, and that is initial velocity. Therefore, the distance from here to here indicates initial velocity. And since this distance is equal to AB distance here, therefore what does AB indicates? Initial velocity. Now here all these velocities have equal values, that is 2 meter per second. I'll take this as only velocity, right? Since the velocity is constant. So therefore AB stands for velocity. So this is velocity. And what does AD stands for? AD from here to here, it's simple, it's a time axis from 1 second to 4 seconds. So it's a time, right? So this is very important step now. We have found area of rectangle ABCD is equal to velocity into time in this velocity time graph. But what is the definition of velocity? Velocity is rate of change of displacement, or we can say displacement divided by time. Now if you do a cross multiplication, you know, velocity into time, look at this, velocity into time will give you displacement. Now since we have a situation where displacement is equal to distance, and why are those equal? Because we are moving in a straight line, and therefore I am going to write in place of displacement as a distance. So velocity into time is nothing but a distance, right? Therefore area of rectangle ABCD, area of rectangle ABCD is nothing but distance covered, and distance covered is velocity into time, right? And therefore what is our conclusion then? Our conclusion is, if you find the area of a velocity time graph, then you will get the distance, right? So if you take the area of this and you find out, okay, it need not be always rectangle, it can be any shape. Since it's a uniform velocity, same velocity is maintained, that's why we are getting a diagram, a rectangle, but it can be of any shape, right? And therefore if you find the area here in this situation, we are going to get the answer, distance covered by the body, right? Now let's take another simple situation, okay? But please remember, what is the area of velocity below the line of velocity time graph? It's a distance covered, because this is required to prove second equation of uniformly accelerated motion. Next, we shall have another situation where there is increase in velocity. Look at this, 2 meter per second becomes 3 meter per second. So 1 meter per second increased, and then another 1 meter per second increase. Okay, and then for the fourth second another 1 meter per second increase, and so on, right? And therefore if you plot the graph, here you are getting for first second here, for the second slightly more, and here little bit more of height because it is 4 meter per second, 5 meter per second, right? And then 6 meter per second at 5 seconds, and you get a line, straight line, but not parallel to either velocity axis, that is y axis, or a time axis. But here also if you find a area below this, okay, and that is going to give distance covered. Please remember this. Therefore this is a very important point here when we prove a second equation of motion. Okay, so now area below velocity versus time graph is distance covered. Now how to find the distance covered here? If I can complete this diagram from here to then here, you will get a rectangle triangle, right? But is this the area? Is this the area below this? We have got an area here also. So let us take the complete area, and therefore here this entire figure is made up of one triangle and another is a rectangle, and therefore we have to we'll find separately the area of this rectangle triangle as well as area of rectangle. Okay, and therefore we will give the name this triangle ABC, and then here EF. So we have ECBF rectangle and ABC a triangle. And what is the area of triangle? The area of triangle is given by half into base into height, right? And this is very simple, length into breadth, and therefore the total area can be the sum of area of triangle ABC, this one, plus area of rectangle CBEF. Okay, now please recall what we are finding now, distance covered, right? Used to start with this, distance covered is equal to, and then you get the second equation of uniformly accelerated motion. So this step is very important step. And now we shall apply the formula, which is equal to half into AB into BC, right? This is the base, plus area of rectangle is simple, CE into EF, CE into EF, right? So this one. Now look at this, AB is given by AF minus BF. And please recall, what is AF? What does this point tells? It's a final velocity. And what is final velocity? Small v. And what does this height tells us? This is initial velocity. In this case, you see initial velocity is 2 meter per second and final velocity is 6 meter per second. If you call this as v, this is u and this is v, small letters. So this stands for u and this stands for v. So what I do is AB I will express in a different way, like AF minus AF from here to here, AF minus BF, right? Or AF minus AB, sorry, AF minus AB, it's not AB, it is AF minus BF. Please correct this, AF minus BF, and you get AB, right? plus CE into EF. Right? Now, at this position, you have to first mention what is given in this graph. Right? And what is given in this graph? First you have to write AF is V. So from here to here, AF is V. Right? I am in few slides I am going to correct. Please consider this AB as BF. AF is V and BF is U. Right? And BF is, that is BF, here is U. This is V, this is U. Right? So here again I am doing here, it's BF. And what is EF? EF is T, it's a time axis. So this you have to mention. And also that you should mention what is the distance curve, what is the symbol which is used in for the distance covered. Now, since this is BF again, since AB can be expressed as AF minus BF and AF is V and BF is U, so AB can be straightway written as V minus U. Please remember. Okay, so half into V minus U into BC plus CE into EF. This is CE into BF. Now, that is going to be, what is BC then? BC is BC. What is BC? This one. BC is nothing but EF and that is T. That is time. And therefore in place of this, half into V minus U into T. And what is CE? CE, as I told you, that it's the initial velocity U into what is this? EF. EF is again T. So you get a final equation here, half into V minus U into T plus U into T. So this is very important. Getting this expression is more important. Half into V minus U into T plus UT. Now here it's very simple. We have already learned V is equal to U plus AT. Now if you take this on this side, V minus U is equal to AT. Right? This is the first equation of uniformly accelerated motion. Now what I am going to do is, in place of V minus U, I'll keep AT. That's why half into V minus U into T plus UT will become half into AT. V minus U is nothing but AT. Right? And UT. Now see, half into A into T becomes AT square. Right? Plus UT. So your final equation is half, S is equal to half into AT square plus UT. Now what is S here? S is the distance covered. The symbol which is given S for this distance covered. So please go through this video again, but this is what the second equation of uniformly accelerated motion. This can even be written as S equals UT. This can be written first plus half AT square. Right? So what is a logic behind the proof of this? You have to prove, we know that the area below this line is a distance covered. So distance covered S is equal to area of this, okay, plus area of rectangle triangle. Now when you find area of this, you get half into AT into T. So this is what you get. And how you get all these steps you should know. Plus area of this, you get UT. So finally it becomes S equal to half AT square plus UT. This is simple step. Okay. So this much you have to in brief understand, and how you got this area, that you have to mathematical equations you have to apply here. So this is second equation of uniformly accelerated motion. But when this is asked to prove on paper, you need not shade this, you need not draw this all, okay, and take it as an example. We have just taken this as an example to understand that how this uniform increase in the velocity, that is uniformly accelerated motion, will give you a straight line. Okay, so you need not draw all those things, you can take out this, right, and even the shading portion also you can take. This should be your graph. You need not even mention what are the values here. It is understood that CE is U, and from here to here it is V, and so from here to here it becomes V minus U. That you can write, and this becomes T. This also is T. This is a time and this is velocity. But before you prove, you have to explain what are U, V, T, A and S which you are going to use in this equation. Straightway don't go for all these things. You have to tell that consider a body is moving with the initial velocity U and final velocity V in time T, and acceleration be A. Let's S be the distance covered by the body, and then you have to explain what is there in the graph. AF stands for V, BF stands for U, EF stands for T, right? And then you have to start this very important step, that is distance covered is given by area below velocity time graph. And then automatically your work starts, and finally you reach this step. Okay, and now how did you get this V minus U equal to AT? First equation of motion, which is shown here. So this complete material, if you can write on paper for the question proof for second equation of motion, you get full marks. Okay, either it will be 4 or 5. Right, so please practice it. It appears to be simple, but unless you practice on the paper, you will not be able to reproduce it during the examination. Okay, so you can save time if you practice. Thank you.